Hello everyone, this is Mr. Avila coming to you from South LA, working on reviewing for a final exam with my Algebra 2 students. Hopefully this helps somebody else out. In our situation, we're still going to be applying exponential functions, but we're going to first switch the color of my pen to blue. That is always a little bit of a pain. And in an experiment, a scientist places bacteria onto a plant. The growth of the population of this bacterium is modeled by P of x is equal to 100 times b to the power of x, where x is the time in weeks following the introduction, and b is a positive unknown base. So using our idea of f of x is equal to initial term times growth factor to the power of x, let's answer that first question. How many bacteria did the scientists initially place onto the plant? How do you know? So since we know that f of x is equal to initial term times growth factor to the power of x, I'm hoping you could easily identify the initial term. The initial term is here. Nope, sorry, I wanted just the 100. The initial term is 100. So since that initial term lines up with the position of the 100, the initial term is equal to 100. Now we got to find the approximate value of b if you know the plant contains 2,000 bacteria after 10 weeks. Let's show our work. So after 10 weeks, so we're going to go ahead and write this P of x is equal to 100 times b to the power of x. Now we're trying to find that value of b. So that we know that if we start with 100 bacteria and we don't know b, but we do know that after 10 weeks there is 2,000 bacteria, then we're going to use this information to be able to solve for b. We will then divide both sides by 100 here to start working on getting our b by itself. So b to the power of 10 is equal to 2,000 divided by 100. That gives us 20. And how do you get b by itself when you have a power of 10? Now we're going to raise both sides to the power of 1/10. Now you could also do the 10th root on both sides. I just taught it here as raising both sides to the power of 1/10. We're going to go from here and jump into our Desmos graphing calculator. So let's go to our scientific calculator here. And we're going to type in our, 20 times 20 to the power of 1 divided by 10. And there is our value, 1.349. So we're going to go ahead and we're going to leave that rounded to 1.349. So b is equal to 1.349. And that is what we call our growth factor. Okay. All said here, this question just asked us for the growth factor. We could then create our exponential function. Our exponential function would be 100 times 1.349 to the power of x, and then answer questions like how many bacteria there would be after 10 weeks, or how many weeks would it take for there to be 10,000 bacteria. But in this case, we were just asked for the growth factor. Thanks for following along, everybody. That's our question number 3. Good luck studying for your finals. Bye.